Welcome back. In the last video, we discussed a little bit more about matrix multiplication, but we're not done there. We looked at two of the main rules of matrix multiplication, and we saw a few errors of what happens if those rules aren't satisfied, particularly if the inner dimensions don't match. So this is what I've been alluding to as one of the most common errors in deep learning, and that is shape errors. Because neural networks are comprised of lots of matrix multiplication operations, if you have some sort of tensor shape error somewhere in your neural network, chances are you're going to get a shape error. So now let's investigate how we can deal with those. So let's create some tensors, shapes for matrix multiplication. And I also showed you the website, matrixmultiplication.xyz. I hope you had a go at typing in some numbers here and visualizing what happens, because we're going to reproduce something very similar to what happens here, but with PyTorch code. Shapes for matrix multiplication, we have tensor A. Let's create this as torch.tensor. We're going to create a tensor with just the elements 1, 2, all the way up to, let's just go to 6, hey? That'll be enough. 6, wonderful. And then tensor B can be equal to a torch tensor of, where are we going to go for this one? Let's go 7, 10. This will be a little bit confusing, this one, but then we'll go 8, 11, and this will go up to 12, 9, 12. So it's the same sort of sequence as what's going on here, but they've been swapped around. So we've got the vertical axis here. Instead of 1, 2, 3, 4, this is just 7, 8, 9, 10, 11, 12. But let's now try and perform a matrix multiplication. How do we do that? Torch.matmul for matrix multiplication. PS, Torch also has torch.mm, which stands for matrix multiplication, which is a short version. So I'll just write down here so that you know. Tensor A, tensor B. I'm going to write torch.mm is the same as torch.matmul. It's an alias for writing less code. This is literally how common matrix multiplications are in PyTorch, is that they've made torch.mm as an alias for matmul. So you have to type 4 less characters using torch.mm instead of matmul. But I like to write matmul because it's a little bit, like, it explains what it does a little bit more than mm. So what do you think is going to happen here? It's okay if you're not sure, but what you could probably do to find out is check the shapes of these. Does this operation, matrix multiplication, satisfy the rules that we just discussed? Especially this one. This is the main one. The inner dimensions must match. Well, let's have a look, eh? Oh no! Mat1 and Mat2 shapes cannot be multiplied. 3 by 2 and 3 by 2. This is very similar to what we went through in the last video. But now we've got some actual numbers there. Let's check the shape. Oh, torch size 3, 2, torch size 3, 2. Now, in the last video, we created a random tensor and we could adjust the shape on the fly. But these tensors already exist. How might we adjust the shape of these? Well, now I'm going to introduce you to another very common operation or tensor manipulation that you'll see, and that is the transpose. To fix our tensor shape issues, we can manipulate the shape of one of our tensors using let's go transpose. And so I'll write here, we're going to see this anyway, but I'm going to define it in words. A transpose switches the axes or dimensions of a given tensor. So let's see this in action. If we go, and the way to do it is you can go tensor B dot T. Let's see what happens. Let's look at the original tensor B as well. So dot T stands for transpose, and that's a little bit hard to read, so we might do these on different lines. Tensor B. Get rid of that. So you see what's happened here? instead of tensor B, this is the original one. We might put the original on top. Instead of the original one having 7, 8, 9, 10, 11, 12 down the vertical, the transpose has transposed it to 7, 8, 9 across the horizontal and 10, 11, 12 down here. Now, if we get the shape of this, tensor B dot shape, let's have a look at that. Let's have a look at the original shape, tensor B dot shape. What's happened? Oh no, we've still got 3, 2. Oh, that's what I've missed out here. I've got a typo, excuse me. I thought I was... You think code that you've written is working, but then you realize you've got something as small as just a .t missing, and it throws off your whole train of thought. So, you're seeing these errors on the fly here. Now, tensor B is this, but its shape is torch.size 3, 2. And if we try to matrix multiply 3, 2 and 3, 2, tensor A and tensor B, we get an error. Why? Because the inner dimensions do not match. But if we perform a transpose on tensor B, we switch the dimensions around. So now we perform a transpose with tensor B dot T, T's for transpose. We have, this is the important point as well, we still have the same elements. It's just that they've been rearranged, they've been transposed. So now tensor B still has the same information encoded, but rearranged. So now we have torch size 2, 3. And so when we try to matrix multiply these, we satisfy the first criteria. And now look at the output of the matrix multiplication of tensor A and tensor B dot T, transposed, is 3, 3. And that is because of the second rule of matrix multiplication. The resulting matrix has the shape of the outer dimensions. So we've got 3, 2, matrix multiply 2, 3 results in a shape of 3, 3. So let's prettify some of this and we'll print out what's going on here. Just so we know, we can step through it, because right now we've just got code all over the place a bit. Let's see here. The matrix multiplication operation works when tensor B is transposed. And in a second, I'm going to show you what this looks like visually. But right now, we've done it with PyTorch code, which might be a little confusing, and that's perfectly fine. Matrix multiplication takes a little while and a little practice. So original shapes is going to be tensor A dot shape. Let's see what this is. And tensor B equals tensor B dot shape. But the reason why we're spending so much time on this is because, as you'll see, as you get more and more into neural networks and deep learning, the matrix multiplication operation is one of the most, or if not the most common. Same shape as above, because we haven't changed tensor A's shape, we've only changed tensor B's shape, or we've transposed it. And then tensor B dot transpose equals, we want tensor B dot T dot shape. Wonderful. And then if we print, let's just print out, oops, print. I spelled the wrong word there. Print. We want, what are we multiplying here? This is one of the ways, remember our motto of visualize, visualize, visualize? Well, this is how I visualize, visualize, visualize things. Shape, let's do the @ symbol for brevity. Tensor, and let's get b.t.shape. We'll put in our little rule here, inner dimensions must match. And then print, let's get the output. Output, we'll put that on a new line. The output is going to equal torch dot, well, our output's already here, but we're going to rewrite it for a little bit of practice. Tensor A, tensor B dot T, and then we can go print output, and then finally print, let's get it on a new line as well, the output shape. A fair bit going on here, but we're going to step through it, and it's going to help us understand a little bit about what's going on. That's the data visualizer's motto. There we go. Okay, so the original shapes are what? Torch size 3, 2 and torch size 3, 2. The new shapes, tensor A stays the same. We haven't changed tensor A. And then we have tensor B.t is torch size 2, 3. Then we multiply a 3 by 2 by a 2 by 3. So the inner dimensions must match, which is correct. They do match, 2 and 2. Then we have an output of tensor 27, 30, 33, 61, 68, 75, etc. And the output shape is what? The output shape is the outer dimensions, 3, 3. Now, of course, you could rearrange this, maybe transpose tensor A instead of tensor B. Have a play around with it. See if you can create some more errors trying to multiply these two, and see what happens if you transpose tensor A instead of tensor B. That's my challenge. But before we finish this video, how about we just recreate what we've done here with this cool website, matrix multiplication. So what did we have? We had tensor A, which is 1 to 6. Let's recreate this. Remove that. This is going to be 1, 2, 3, 4, 5, 6. And then we want to increase this. And this is going to be 7, 8, 9, 10, 11, 12. Is that the right way of doing things? So this is already transposed, just to let you know. So this is the equivalent of tensor B on the right here, tensor B.t. So let me just show you. If we go tensor B dot transpose, which original version was that, but we're just passing in the transpose version to our matrix multiplication website. And then if we click multiply, this is what's happening behind the scenes with our PyTorch code of matmul. We have 1 times 7 plus 2 times 10. Did you see that little flippy thing that it did? That's where the 27 comes from. And then if we come down here, what's our first element? 27 when we matrix multiply them. Then if we do the same thing, the next step, we get 30 and 61 from a combination of these numbers. Do it again. 33, 68, 95 from a combination of these numbers. Again and again, and finally we end up with exactly what we have here. So that's a little bit of practice for you to go through, is to create some of your own tensors. Can be almost whatever you want, and then try to matrix multiply them with different shapes. See what happens when you transpose and what different values you get. And if you'd like to visualize it, you could write out something like this. That really helps me understand matrix multiplication. And then if you really want to visualize it, you can go through this website and recreate your target tensors in something like this. I'm not sure how long you can go, but yeah, that should be enough to get started. So give that a try, and I'll see you in the next video.